Hey guys, welcome back. Today is day 70 and today we're going to start to learn how to solve a quadratic. So I want you to try the warm-up first because this is a new topic. Pause the video and then you can come back. So we're looking at the graph of a quadratic actually makes the shape of a parabola, and you can put these into Desmos and you can see the shape of the graph. Now the x-intercept is the point where the graph touches the x-axis. So here's our x-axis right here. So in this case, the x-intercept would be at -1 and 0, okay? And that is also known as the zero, or sometimes it's called the root, or the solution, or the answer, okay? We're actually really interested in where that parabola hits the x-axis. So sometimes we have one x-intercept, sometimes we have two, and sometimes we don't have any, okay? Now remember the domain. The domain would be your x values, okay? So your x values in this case, if you look at this, is the x values could be anything, okay? Because this graph is going on and on and on forever. So your x's could be any value. It's going to continue on. So you're going to say that x is an element of the real number set, or all real numbers, okay? So that's how we can write that, or x is all real numbers. Now our range is our y values. Now our y values are a little bit different, okay? Because our y values, the lowest y value that we can have is actually right here at 0. So y has to be greater than or equal to 0, okay? So that's the difference between the domain and the range, all right? Now if we look at the second example we have in the warm-up, the x-intercept, if we notice here, we've got one here and we've got one here. So we've got two of them. So the x-intercepts would be at negative, looks like it's at -2, 0 and +2, 0. All right, in this case, the domain, which is our x values, could again be anything because this parabola goes on forever. It's going out at just a little bit, but it's going to continue on. So we're going to say that it can be any number. It's an element of the real number set. All right, and the range, though, if you look at the bottom point here, your y values, -1, 2, 3, 4, your y values would have to be greater than or equal to a -4 in this case. Okay, so that's how we do the warm-up. All right, so getting into your notes now. So we're looking at 70A. Again, to solve a quadratic equation, you're going to solve the equation, which means you find the zeros or the x-intercepts or the value of or the roots. Any of these words mean the same thing, okay? So there's multiple ways that you can solve a quadratic equation. All right, one of the ways you can start by factoring it. So we have two binomials that are multiplied together. We set them to 0 because 0, the output of 0 is where it's going to intercept the x-axis. So if we do that and we have x plus 3, all right, if x plus 3 was equal to 0, then the whole thing would be equal to 0. And x minus 5 is equal to 0. Okay, hold on a second. Okay, so in this case, we could set x plus 3 equal to 0 or x minus 5 equal to 0 and solve for x. So we do that by subtracting 3 from both sides. In one case, our x is -3. And then in this case, if we added 5 to both sides, our x would be equal to 5. So we have two solutions, okay? We write this as a solution set. Notice these are not parentheses, okay? They're brackets. We start at the lowest value, and then we put the highest value, okay? So in this case, the parabola intersected the x-axis at two places, okay? So we're using the zero product property, which means each of the factors can be set to 0 to find the solution. So with number 1, if we set x plus 7 equal to 0 and x plus 12 equal to 0, we get our two solutions. X is going to be equal to -7 and x is going to be equal to -12. Okay, so in that case, our solution set is -12, -7. Okay, I like to start at the lowest value. All right, number 2, again, we're using the zero product property. All right, meaning if any factor is 0, then the whole equation sets to be 0. So 2x plus 3, we're setting it to 0, and x minus 5, and we're setting it to 0. So we're going to subtract 3, we get 2x is equal to -3, and then divide by 2, so we get x is -3/2, and here our x is 5. So our two solutions would be -3/2 and 5. Okay. All right, so if we looked at the graph, we could do it, okay? We can identify the zeros. Notice we have a graph, we put it into Desmos. So at first glance, you can just look at it and see, well, the x-intercepts would be at, they're going to cross right here at -3 and +2. Okay, let's see if that works out. All right, but what we're going to do is take that quadratic and we're going to factor it. So we're going to factor it using the x method that we learned. Okay, so when we did that, our a is 1, our b is 1, and our c is -6. So we put a -6 up here, 1 down here, and we can say 3 times -2. Always divide by that leading coefficient. All right, so what happens is, if we take these two binomials, x plus 3 and x minus 2, and we set them to 0, okay, let's see what happens. So x plus 3 is equal to 0, and x minus 2 is equal to 0. Using the zero product property, our x is -3, and our x is 2. Okay, just like we got looking at the graph. All right. So you can use the graph to kind of prove your work. All right, so if I look at the next one, x squared minus 36. Okay, I cross here, I cross here. If I count 1, 2, 3, 4, 5, 6, and it's -6. So my x is -6 and 6. Okay, now I'm going to factor this one because they're both perfect squares. I'm going to use the difference of perfect squares, x plus 6, x minus 6. Then I set them to 0 using the zero product property. So x plus 6 is equal to 0, so our x is -6, and x minus 6 is equal to 0. So here our x is +6. Again, showing that our solution is -6 and 6. Okay, so if you want to pause the video right here and try a few of them, okay, you can see, actually, if you try to factor number 5, maybe it's not a good one to try on your own because it is an example of what happens when we have a prime. All right, so we go to factor this, and we put this up top. We have a 3 and a 1, and there's nothing that we can actually multiply to get 3 that add up to 1. So, and then looking at the graph, we can see that that graph never crosses the x-axis. So this is an example of no solution. All right, notice right here, it never crosses the x-axis. Okay, the next one, we cross only at one point, so it looks like our solution is going to be just -2. Okay, but let's factor it and see. So we start off and let's do our x. We've got 4 and 4. We know we can multiply 2 times 2 to get 4, and it adds up to 4. So our two binomial factors would be x plus 2 times x plus 2. All right, setting either one of those to 0, x plus 2 equals 0, we end up with our x is -2 in both cases. So this is an example of having only one solution because they would both be the same. So it's just -2. Okay, so if the equation is not already factored, then you must factor it first. Okay, so if you look at the example, all right, we looked at this and maybe we did the x and we have a 6 and a 7, and you can do 6 times 1. All right, so that's how we got the x plus 1, x plus 6 equal to 0. All right, so with number, and then from there, you can set either one equal to 0. Okay, so x plus 1 is 0. So our x is -1, and x plus 6 is 0. So x is -6. So the solution for that would be -6, -1. Okay, so let's look at number 7. I'm going to start by making my x. I'll put 18 up top, -9 down at the bottom. We're going to multiply -6 times -3. Divide by that leading coefficient. All right, when we do that, we end up with x minus 6 times x minus 3 Zero product property, we're going to set it to 0, and we're going to split it up and solve. Okay, so x minus 6 equals 0. Our x is 6. And x minus 3 equals 0. Our x would be 3. So our solution set would be 3, 6. Okay, with number 8, okay, we're going to always start out and factor out our greatest common factor. In this case, the greatest common factor is 5x. So we're left with x minus 8 equals 0. Now, it looks a little different, but the zero product property still works. So one of the factors is 5x. If we set 5x equal to 0, or we set x minus 8 equal to 0, we can get our two solutions. In this case, x is 0, and x would be equal to 8. So our two solutions would be 0 and 8. Okay. Number 9, all right, so if the equation's not already set to 0, you have to make it equal to 0 and then factor. So you got to move it around a little bit. So we're going to bring the 5x over by subtracting 5x. So I'm going to say x squared minus 5x. Then I'm going to bring the 6 to the other side by adding 6. And now I can set it equal to 0. Once I do that, I can factor, all right, I know my a, b, and c. 1 times 6 is 6. I've got a negative 5. So I can say negative 3 times negative 2. Again, I always divide by that 1. Okay, so when I factor it, I get x minus 3 times x minus 2. I'm going to set it to 0. And from there, zero product property, I'm going to set each factor to 0 and solve. X is 3. X minus 2 is 0, so x is 2. So my solution is 2, 3. All right, so with number 10, I'm going to start by bringing the x to the other side. So I've got 2x squared minus 7x equals negative 3. And then I'm going to add 3 to both sides. So 2x squared minus 7x plus 3 is equal to 0. So when I start out, I make my x. I've got 2 times 3 is 6 and negative 7 in the middle there, down at the bottom. So I can say negative 6 times negative 1. I'm going to divide both by that leading coefficient. All right, so I get negative 3, and I get, so when I factor it, I get x minus 3. And then I have, remember, the 2 comes up, 2x minus 1. And both of those are going to be set to 0. Okay, so now I can split it up and say x minus 3 equals 0, or x is 3. Or I could say 2x minus 1 equals 0, 2x equals 1, x is 1/2. Squeeze that in. So our solution would be x is equal to 1/2 and 3. Okay, so now we get to the situation where we want to solve a quadratic equation that does not have an x term. So all we're going to do is rearrange the equation so it's in the form of x squared is equal to d. And then we find the square root of both sides. So we're basically isolating x. We're getting it by itself. So we're following the golden rule of algebra, okay? And when we do that, you'll notice we divide both sides by 2. So you're getting x by itself. X squared is 4. Once we get it into that situation, we can take the square root of both sides. And x is actually going to be equal to plus or minus 2. Because if you recall, the square root of 4 is not only 2, it's also negative 2. Because negative 2 times negative 2 is positive 4. So our solution here would be negative 2 and 2. All right, so when I solve this one, I end up with x squared is equal to 0. Okay, I just brought the 18 to the other side. I then take the square root, and x is equal to 0. So in this case, this is an example of just one solution. All right, it's just going to be 0. And in this situation, I'm going to subtract 12 from both sides. X squared is equal to negative 7. Well, if you try to take the square root of a negative number, you're going to get that there's an error. So we're going to say that there's no real solution, not just no solution, because actually this will introduce something called the imaginary number system instead of the real number system. We're not there yet, so we're just going to say there's no real solution for that example. Okay, so I highly recommend, all right, you can look at the exit ticket on the back of the warm-up, but work on 70B, and don't forget about your JLabs. Bye.